Okay, let's try the two clicker questions from exam number 2, okay, which again are just taken from the lecture notes. And the first clicker question says you have a table, a mass in contact with the table, and another mass sitting on top of that. And you pull this mass towards the left, and you ask for the directions of the friction forces in M1 and M2. Now, really, the key concept in answering this question is that friction opposes motion. Okay, so if M1 is trying to slide to the left of M2, that means the force of friction on M1 due to M2 is to the right, okay, because it's resisting the motion of M1 to the left. Okay, now likewise, the friction on M2, well, one way to answer that is to say, well, this is an action-reaction pair. The force of M1 on M2 equals negative the force of M2 on M1. So the force of friction on M2 has to be in the opposite direction to the left. That's one way of answering it. Another way of seeing this is that you can imagine when you do this, you're pulling M1 to the left, but you're also pulling M2 to the left. Well, what's pulling M2 to the left? M1 is being pulled to the left by the pulling force, but M2 is being pulled to the left by the force of friction, accelerated to the left by the force of friction. So that means that it must be pointing to the left. So that's another way of explaining that. But in any case, it's part D, or answer D, that says that the force of friction is to the right on M1 and left on M2. Okay, so the key thing in explaining this is this concept that the friction opposes motion and describing what the motion is. Okay, problem 2, or clicker question number 2, has a body that's moving up a meter, over 2 meters, down 2 meters, then back to the left 2 meters, and asks you what is the net work done by gravity. Well, the only thing you have to worry about to calculate this work is the displacement in the direction of gravity. And so ignore all this motion and ask, well, what is this displacement? And the net displacement is you've gone down 1 meter. Because remember, gravity is down, and work equals force dot displacement, the component of displacement in the direction of gravity. Okay, so it just means we have to work out the values. The force is mg, the displacement d is 1. Okay, the mass is 1 kilogram. G, you're told to use g meters per second squared, and the net displacement is 1 meter. Now you have to pick directions, but note that mg and the displacement are in the same direction, so that means you're doing positive work. Okay, so your answer is plus 10 joules, which is none of the above. Done.